Okay, what you can see here is the area of this rectangle. Now, you know how to find the area of a rectangle. 12 times 8 is 96 centimetres. Sometimes you get asked to find out what the biggest area of the rectangle could be, given that these numbers have been rounded to the nearest centimetre. So you've got to say to yourself, what's the biggest number 12 centimetres could be in order to get round into 12 centimetres? Well, we say that that upper bound will be 12.5 centimetres, and 8 centimetres would be 8.5 centimetres. So you do 12.5 multiplied by 8.5, which miraculously I know is 106.25 centimetres squared. And that is the largest area that this rectangle can be, given that these numbers have been rounded to the nearest centimetre. We're going to have a look at what happens when you're asked to work things out using upper and lower bounds. This is the trap that they set for you, and it happens a lot because in situations like this where you've got distance divided by time, if you think about it, when you divide something by a big number, the answer becomes smaller. If you divide by a small number, the answer becomes bigger. So if you take, for example, 10 divided by 2, that's 5. You make the number on the bottom 10 divided by 2, instead of that make it 10 divided by 5, the answer is 2, so the answer becomes smaller. What we're saying here is a man has run 100 metres in 13 seconds. Now 100 metres is measured to the nearest metre. So we know that it could have been 99.5 metres at the low end and 100.5 metres at the high end. So that's the lower bound, that's the upper bound. 13 seconds has been measured to the nearest second. So it could be 12.5 seconds, or it could be 13.5 seconds. What we have to do is say, what is the greatest speed that he could have done this in? The greatest speed would result from the longest distance run in the shortest time. So you would do 100.5, which is the longest possible distance, divided by 12.5 seconds, which is the shortest it could have been. So that's 8.04 metres per second.